Hello and welcome back to another video. In this problem, we're asked if a bacteria population starts with 100 bacteria and doubles every 3 hours, then the number of bacteria after t hours is n is equal to f of t is equal to 100 times t to the 2/3. For us to find the inverse of this function and explain its meaning. So if we have n equals 100 times t to the 2/3 as our original function, to find the inverse, we have to swap the variables. So t equals 100 times n to the 2/3. Now we just have to solve for n. Dividing by 100, get t over 100 equals n to the 2/3. So to get n on its own, we raise this to the 3/2 power. Therefore, we have n to the 2/3 times 3/2. This is 2 times 3 is 6 over 3 times 2 is 6. N to the 6 over 6 is n to the 1. So this is n equals t over 100 to the 3 over 2. Turning this into an actual function, right? N is equal to f of t in the original function. Therefore, n is equal to the inverse of t in the new function. And we have to be careful here because these aren't just random variables. These are representing real-life phenomena. This is the number of bacteria after t hours is n equals f of t. The inverse is the number of hours at a certain amount of bacteria. So it's the opposite. So here we plug in the time to get the bacteria. Here we plug in the bacteria, n, to get the time. So this function is n over 100 to the 3 over 2. When will the population reach 50,000? Time at a bacteria, we just have to plug in 50,000 into this equation. So f inverse of 50,000 equals 50,000 over 100 to the 3 over 2. 50,000 divided by 100 is 50. 50, therefore, is raised to the power of 3 over 2, which is roughly 353. So it'll take roughly 353 hours if we double every 3 hours to get from 100 to 50,000.